Well, okay. I don't know whether I'm more relieved or you are that this is the last one of the series. It's to be about, well, I'm not really quite sure how to express it, really. The way we've been thinking of it is philosophical. Consequences of, and now I'm going to abbreviate free will theorem like that every time I use it. But it's not only philosophical consequences, it's sort of relationships of the theorem to things that are customarily considered philosophical. And it has some. I mean, you may remember that last time I spoke about, which with the same degree of approximation can be called scientific consequences. And at least the second part of this lecture is going to be concerned with arguments towards free will. And to the mathematicians, that's a little bit strange, because if you remember this second time around argument, if now is the second time the universe is playing, so to speak, and we are being fed exactly the same sense impressions as we were the first time around, then the second time around there isn't free will, and so the world is deterministic, even if the first time around wasn't. So that means that if I meet somebody who is a really convinced determinist, there's no logical argument, or at least no, I prefer to use the word deductive, argument from deductive logic, that I can use to convince my opponent he's wrong, so to speak. I mean, that the world isn't deterministic. And that is what we mathematicians or logicians would call a consistency proof for determinism. There's no hope of disproving a determined determinist. Okay. And this business of consistency proofs is very easily misunderstood until you've met a few. Logicians have met consistency proofs all over the place, and we've developed a certain amount of contempt for them from familiarity with them. We know that consistency has really very little to do with truth. I mean, if something is inconsistent, then it can't be true. But if something is consistent, that's not very strong evidence for its truth. And so I'm going to mention some famous examples of consistency proofs. The oldest is the consistency proof for non-Euclidean geometry. And in the modern version of that, you define straight line to be the universe, the plane, say, is the interior of a circle. And straight line means a circle, or an arc of a circle, that's perpendicular to the boundary. And distance is defined, and it's not equal to the usual distance. So let me sort of summarize. Straight lines are not the usual straight lines. Distance is not the usual distance. But nonetheless, if you redefine what all the words mean, you can prove that this is a model for non-Euclidean geometry. That's to say, through a given point, there can be more than one line that doesn't meet a given one. In Euclidean geometry, Playfair's axiom tells you that there's just one straight line through a given point that doesn't meet another given line. Okay. Well, non-Euclidean geometry is consistent, so is Euclidean geometry. And yet they make different assertions. The thing is, they're not talking about the same thing, really. it is, it's possible to prove that no contradictions follow from some assertions without those assertions being true. The one I like most is a rather less familiar one, but it's easier to sort of understand what goes on. In set theory, there's an axiom called the axiom of infinity, whose sole function is to guarantee that infinite sets exist. Now, regardless of what you think about whether that axiom is likely to be true or not, there's a wonderful proof of the consistency of the denial of that axiom. And it consists in the following. You throw away any set that's infinite. And not only that, but you throw away any set that has an infinite element. And you throw away any set that has a set that has an infinite element, and so on. So you throw away the vast majority of sets, it may be. Well, we don't know, maybe the axiom of infinity is false, maybe there aren't any. But in any case, if there are some infinite sets, you throw them all away, and then surprise, surprise, you have a model for set theory in which there aren't any infinite sets. So it denies the axiom of set theory. That sort of seems to me cheap. I don't know whether you agree. You take a model in which the thing you're denying is true, and then just make it false. In fact, there's a similar one for, this one I gave you for the consistency of determinism is really rather like that. You take a model which may have had free will in it originally, and then play it second time around and it doesn't have free will. It doesn't really say anything about the truth of free will. So you see there are cases where two mutually contradictory statements, I can add statement A, or I can add statement not A, the denial of A, to some previous axiom system, and each of them might be consistent. So consistency is no guarantor of truth. Okay? So what does that mean in respect of our thing? It means that when I proved the consistency of determinism, this is not by a very scientific model, the second time around model, but still, it certainly suggests that determinism is consistent. That doesn't really say anything about whether it's true or not. Now, there's this famous theorem of Gödel that I imagine some of you at least have heard about. And there is an analogy of this free will discussion with Gödel's theorem. Gödel showed that truth can't be equated with provability from some sort of axiom system. I think of that as, how can I say it, as mechanical provability or something. In fact, Roger Penrose talks about the machine in this connection. But anyway, the machine is a machine for proving theorems. And Gödel's theorem tells us that the truth of an arithmetical statement is really not the same as its provability. I mean, there's a subtle question involved there, but let's just stick it at that for the moment. Truth cannot be equated with provability by any mechanical procedure. And there's a vague analogy, because the free will theorem says, if we have free will again, but anyway, let's suppose that for the moment, that particles also have free will. In other words, their behavior cannot be explained deterministically or mechanically. There's no way in which there's some sort of mechanical rule that's explaining what particles do. So, well, I hope you see that there's more than a vague analogy between the two. By the way, I'm going to, throughout this lecture, every now and then, throw up a slide that looks very like a slide you've seen before, at least if you've attended all the lectures. Well, that's partly because some of you haven't attended all the lectures, and partly because I want you to sort of recall things, I've allowed myself to edit them to sort of make additional points. And one of them is this remark, which I really think, every time I've mentioned it I've said this, but it's worth saying again, I really think that Simon and I are the first people to make this remark, that you can't explain the behavior of particles in this world by what I call injecting random numbers into a universe that has deterministic laws, apart from the fact that you've injected these random numbers into it. And if you remember, I mentioned what happens in backgammon tournaments, which is the dice are thrown beforehand, but as far as the players are concerned, that makes no difference. That's quite an important point, because it allows us to sort of treat the random numbers as historically determined. They were determined before the universe started, or at least they might as well have been. We can't tell. Okay. So, usually people have tended to equate in philosophical decisions the opposite of determinateness with randomness. Einstein himself did that when he made his famous statement that he cannot believe that God plays dice with the universe. That was in response to Bohr's observation that quantum mechanics didn't appear to be totally predictive. Well, if you remember what we did, we have a different opinion, Simon and I. Simon perhaps more particularly than I do. There's a third alternative, what we call free. Or maybe, technically, we use a slightly different word, party-free or semi-free. The free decisions taken by particles cannot be explained by random numbers. So this is something that's different from both randomness and determinateness, or deterministic behavior. And we sort of, far from regarding randomness as the opposite of determinism, we regard them as both in the same scale pan, roughly speaking, and the opposite of both of them is free. So, but free has a very technical meaning, let's say. It refers to the kind of decisions that particles can make. And what's the difference? Well, we don't actually sort of really understand this situation terribly well, but we do have one discriminating feature, which is that both random decisions and determined decisions can be taken ahead of time. I mean, if they are determined, then really that means that you know what the answer is before they happen, before it happens. And if they're random, well, no, it doesn't mean that you know what it is before they've happened, but you might as well throw the dice before the universe starts. That makes no difference, according to the notion of classical random numbers. So they both go on the same scale pan, so to speak. They can be taken ahead of time, and it doesn't affect the theory. It's a very peculiar situation. Whereas you can't do that with free decisions. You can't pretend that they were there before the time. So here's what I want to say about that, that traditionally, every philosopher, I think, I've never seen any counterexample to this, but maybe I don't believe there is any limitation to what philosophers say, but traditionally, most philosophers have opposed determinism by randomness. And then you have this sort of curious thing. Philosophical discussions of free will are mostly concerned with the question of whether we're responsible for our actions. I performed the crime. I mean, I did the crime, whatever it is. But I'm not responsible because the world is deterministic. and so I'll defend myself by saying I just had to do it. Okay, that's a fair legal defense. So what happens if, that's what, some people might say, what convinced determinists might say. They might say the world is deterministic. Yes, I admit I was the criminal, but how can I be held responsible? On the other side, people say, it doesn't really help to say that the world is not determined. Because after all, if what made me do it is a random sort of jerk, a tick, I wasn't in control, then equally I can't be held responsible for my actions. And if you think that the opposite of determinism is randomness, then you can't hold anybody guilty, basically. Okay? Either it was a dice throw that determined what you did. Okay, but they sound very similar to me because I'm so used to thinking of the dice as the same as determinism. It's rather similar. But, okay. But, we did one thing, Simon and I. We proved that the opposite of determinism isn't randomness, whatever it is. The free kind of behavior, and we're just calling it free, it's a technical term for a particular kind of freedom that's exhibited by elementary particles. Well, it is at any rate on the assumption that we have free will. I'm making that assumption for a time. That free behavior is neither deterministic nor random. And at least you can see that that might open the door to questions of moral responsibility. Maybe we can be responsible for our actions because they're free, whatever that means. I won't pretend to know very much about what it means. It's a subtle question. Okay, let me switch off for a time and say, I must really try to remember to switch off this screen every now and then. So what am I going to do in the rest of this lecture? Well, broadly, I'm going to announce a number of arguments in favor of free will. Now, the consistency of determinism means that they can't be deductive logical arguments. I can't hope to give a rigid proof which, you must accept that free will exists. I think it's true to say, I don't really know, that free will is a minority position in philosophy departments. I sort of believe that's true. It also seems that in the biological sciences, people are more and more coming to believe in determinism. And I find that absolutely astonishing. Especially, well, I'm going to say later on that there's no evidence for determinism. And so how people have come to believe it so frequently, I don't know. Maybe you won't believe me when I say that. It seems a naive thing to say. I'm not ashamed of saying naive things. Let me turn on to this thing here. And let me remind you, this, how can I say it? This is one of several slides that I've copied from earlier lectures, possibly with slight changes. Here, the main change has been the title. So let's. These first two are statements by philosophers. They really are scientific statements, and so they belonged last lecture, where they were. But I want to make them again anyway, because I think they're quite interesting. At least they were made by famous philosophers. Do you remember Descartes had this dualism? He believed our minds had free will, or our spirits had free will. Nevertheless, he thought that things outside those minds were mechanical. Even our bodies were mechanical. So that's what I'm talking about when I say determinism, the material world. But he did two things. He said the material world, the bodies are deterministic. The bodies, both our bodies and the bodies in the sense of physics outside us, but the will is by its nature so free it can never be constrained. That's actually disproved. That's because he managed to make two assertions. He said, we had free will. That's the second assertion there. But things outside us, the material world, does not have free will. It's deterministic. That's directly contrary to the free will theorem. So it's false. Doesn't matter how famous the philosopher was who said it, it's false. Leibniz's principle of sufficient reason is not quite at the same level. So he announced this principle, which sounds very sensible, that nothing happens without a reason why it should be so rather than otherwise. In other words, if A happens rather than B, then there must be a reason why it was A. That sounds very likely. It sounds a good principle. But if we have free will, Leibniz's position on free will is harder to understand. I have a volume of selections from Leibniz which I was reading to put me to sleep. It was a very good putter to sleep. He makes numerous assertions. It was never terribly clear to me exactly what he thought. So I haven't granted him the belief in free will. I don't know whether he believed in free will or not. But if human free will exists, then in fact this principle of sufficient reason is false. The particle can give you the answer 0 or the answer 1 in a certain experiment, and there is nothing in the entire history of the universe before that time which explains it. Okay. Well, now I'm beginning to enter the sort of contentious part. Do you remember what the theorem said, the way I announced it the first time? This thing called min, this principle, was deduced from human free will. It basically said a human can decide which one of 40 or 33 buttons to press, and that they can decide that independently of the past history of the universe. Okay, so it says if humans have that amount of free will, then particles have a rather smaller amount of free will. They can, well, I use the term decide, many people don't like that. They can decide whether to give the answer 0 or 1. Well, no, let's not use the term they can decide. They can give the answer 0 or 1. They don't have to decide to give it before they give it. But if they give it, that's good enough. Okay, now, well, let me proceed to give you... oh, no, sorry, this is not a terribly good reason. It's a reason, but it's a sort of pragmatic reason. Science becomes impossible if experiments can't freely choose the experiments they perform. You see, suppose I decide, to test a physical law, and it says if I press the left-hand button, one thing happens. This is my conjecture. And if I press the right-hand button, another thing happens. Okay? And then I press a certain button. And I turn out to press the left-hand button, and the thing that I said happens. It turns out, though, if I don't have free will, maybe I couldn't press the right-hand button. Maybe nature is in some kind of awful conspiracy to prevent me from doing the experiment I want to. If I don't have free will, then how can I know that that nature just sort of decided to let me do only the experiments that confirmed, or maybe only the experiments that denied my prediction, and not the other ones? We make this assumption of free will every time we do a scientific experiment. We presume we could have done otherwise. And if in fact that presumption is false, then it's hard to see what the logical justification for scientific assertions is. That I'll count as an argument in favour of free will, but I will admit it's a rather peculiar argument. I find it sort of quite convincing. I don't understand, what you can make of science if you believe that you were just forced to do all the experiments you did and not the other ones. Okay. But one of the most convincing arguments is what I call the surprise argument. Now remember, this is not a deductive logical argument. Suppose P implies Q. P is some proposition, and P implies, we usually use this kind of arrow for Q. Then, how can that provide any evidence for P? I start by assuming P. So if it implies any evidence, it must be some sort of circular evidence. Nonetheless, it's really a quite convincing argument in some circumstances. Let's suppose that P implies Q, and Q is a surprise. Well, the concept of being a surprise is not usually part of formal logic. But, it really is a surprise. But turns out to be true, despite the fact that it was surprising. Okay, then this is evidence for P. It's not absolutely convincing evidence. It depends how much of a surprise it is. It depends all sorts of things. It depends how likely P was a priori. It's certainly quite something. So let me tell you what P is in my thing. P is the assumption that humans do have free will. We know we can't prove that by the second time around argument, but let's just suppose it's true for a moment. Then it implies that quantum mechanics is incomplete. It's not. Now, that was a very great surprise when it was discovered in the 1920s, because physical theories up to then had usually been, at least in principle, complete. In the first lecture, I put up Laplace's famous statement that if we knew the positions and velocities, or positions and momenta of all the particles in the universe, if an intelligence knew them, then that intelligence, provided it was intelligence enough, could work out exactly what happened. That was sort of true of old-fashioned physics, of Newtonian dynamics. But it was such a great surprise when it was first discovered that people tried to explain it away. And some of them have been trying to explain it away ever since, basically. They don't believe that quantum mechanics is incomplete or something. They try and escape that implication. But if we suppose human free will, then we get an explanation for why quantum mechanics is incomplete. Because there's human free will. And by the free will theorem, that implies that you can't predict what particles will do. It's not just that you can't predict them, they don't even know, to use anthropomorphic terms, what they'll do. They haven't decided yet. Given all the past history that we sort of usually suppose in trying to predict what particles will do, that's not enough. Okay. So I ask you to consider whether human free will might not be the explanation for that. Why? Suppose the world is deterministic. I'm asking you to suppose the human free will exists. Well, suppose it doesn't for the moment. Let's argue in the other direction. And suppose the world is completely deterministic. Don't we need an explanation for why it seems to be, free will seems to exist? Dennis Overby, who's a New York Times science writer, is apparently completely convinced that the world is deterministic. So in particular, Dennis Overby doesn't have free will, according to Dennis Overby. But then he describes free will as the necessary illusion. He maintains, going about his ordinary life, he just has to believe in free will, even though it's not true. How he's so convinced that it's not true, I don't know. But, why does it seem to be true? Don't you think that needs an explanation? If it's not, well, you see, if free will exists, it explains something. Determinism explains nothing. Well, that's perhaps an outrageously oversimplified thing. But anyway, so let me remark what I've said before. The free will theorem implies not only that quantum mechanics, or theories extending quantum mechanics, as in earlier statements, not only that those theories are incomplete, but no correct theory can possibly be complete because, well, the particles haven't yet decided what they're going to do. So how on earth can you predict what they're going to do if you're right? So no correct theory. So this incompleteness is a merit, not a defect. This is an old slide of mine. Okay. Now let's see something else. If we suppose that we have free will again, then the free will theorem says that elementary particles already have their own small share of that desirable commodity. At least I think it's desirable. And that suggests how we come to have free will. Namely, somehow we get it. We're made of particles, after all. Those particles, particularly the ones inside our brains, may be sort of sampled by our brains in some clever way, and maybe that leads to our own free will. So let's see what's happened. Free will, the assumption of free will, suggests why we have free will. Just the assumption that we do have it, without any explanation of why, suggests a reasonable explanation of how we come to have it. That's surely some kind of evidence in favor of free will. Wait a moment. Whoops. Okay. So let's play the opposite card, so to speak, the card from the other side of our heart. What does assuming determinism suggest to us? Nothing, basically. Determinism is determinism. Everything is the way it is, and it couldn't be anything else. And we don't, in particular, get an explanation for determinism out of the assumption of determinism, nor do we get an explanation why we seem to have free will. It's just inconsequential. It has no consequences. I'd like to be proved wrong, by the way. If any of you violently disagree with me, please sort of say so later. Now this is related to a sort of interesting point in philosophy. The philosopher Robert Nozick, who died a few years ago, wrote a very influential book, and he talked about self-subsuming concepts. I think he basically chose the wrong property, this self-subsuming business, to talk about. So let me say what I prefer to talk about. Ineluctable concepts. Ineluctable means that literally it means you can't struggle out of it. And I noticed a number of these concepts, in particular probability. When I attended a course on probability in Cambridge as a student, I was disappointed with all the definitions of it. They all seemed to assume the concept itself in some sense. And I thought this was profoundly unsatisfactory. And then more recently, I've realized that deep concepts tend not to be explicable in terms of earlier concepts. That's why they're deep. And so you can't define probability in terms of things that don't mention probability. Now, I think Nozick sort of seized on this property. If you try to define probability, then you find yourself assuming probability in some form in the definition. And so that's the thing that Nozick calls self-subsumption. But for me, self-subsumption is a symptom of the disease or whatever it is. It's not the defining property of what we're really talking about. The defining property that we're talking about is ineluctability. You can't struggle out of this concept in terms of an earlier one. There are lots of examples. One of them is randomness. I have never learned what a random sequence was. But another is the concept of probability. Another is the concept of computability in some sense, but never mind, I won't worry about that. What am I trying to do? I'm trying to sort of, in this famous phrase of Wittgenstein's, I'm trying to whistle around something that I can't actually talk about very precisely. It is that we should sort of expect subtle concepts to be hard to define. And we should appreciate that as that's a positive virtue almost in a concept. It's a sign of deepness. Okay. Yeah. This is perhaps the most contentious thing that I have to say. There is no evidence for determinism. This absolutely shocked me, and if any of you find it shocking, I hope you will go through the education process that I went through. Okay. Well, I've mentioned I've given lectures on this sort of subject in many, many places. Usually it's 1 hour. I don't know whether you have been gifted having it in 6 or whether you have something to complain about in having it in 6. Usually it's 1 hour and we get to the point rather more quickly. But I enjoy the conversations I have with people afterwards. Somebody comes up and says something, and, they give me their opinion about free will or determinism or whatever. And every now and then, some of them are determinists. And they rather expect me to argue against determinism. But of course I don't, because I know there's no argument against determinism. I gave you an argument that proves it consistent. Well, there's no logical, totally deductive argument against determinism. And I found a much better way of proceeding is to say, well, how did you come to be a determinist? Did you have any evidence in favor of determinism, for instance? And this is, this gets much more interesting replies anyway. You see, the usual thing is a belief that physics is determinist. Now, this was true of Newtonian dynamics. And then later on, exactly the same mathematics that worked for Newtonian dynamics, gravitational fields and so on, worked for electric and magnetic fields. And so, those theories went on being deterministic. And then if your education stopped before you had a quantum mechanics course, well, you can still be very highly educated, and you can sort of believe that physics is deterministic. Okay, but physics hasn't actually been deterministic for a good 80 years or more. Okay? And so, now let's delete that history that we believed, with good reason, that physics was deterministic. We had very, very successful physics, which was deterministic. But no, things were found to be wrong with it later on. Is there anything else? Well, some people have pointed to the time reversibility of physics. I was absolutely amazed when I heard a very intelligent graduate student do this the other day. What time reversibility of physics? Have you ever seen... well, how can I say it? Have you ever seen a movie run backwards? It looks different. It really does look different. It doesn't look at all like this movie run forward. So if you believe that physics is time reversible, you've got some explaining to do. Why you believe it? Okay. Well, the answer is you believe it because you were educated, probably very expensively educated. You learned these theorems that Newtonian mechanics is time reversible. So the theories of electricity and magnetism that were developed in the 19th century. Then there's this other thing, the unitary development. Do you remember this discussion of unitary development versus collapse, or entwined with collapse? We have in the theoretical understanding of quantum mechanics, which is rather curious, but the standard picture has periods of unitary development which are beautiful and smooth and understandable and predictable and deterministic, alternating with collapse. And the part that we understand is this unitary development part. We don't understand the collapse. But anyway, then, a general relativity. Okay, now there's a thing one does in general relativity in explaining how things work. All the dynamics is geometric in general relativity. We have curvature of the world. And this world is a four-dimensional space-time continuum. And the older authors used to say that we were dragged across this, as time went on, we were dragged across in a particular path in this space-time continuum. But the geometry determined everything. Well, it's not clear how much credence we should place in that. After all, if we have free will, then a plausible case can be made that Theodore Roosevelt did not have to build the Panama Canal. Decide to build it. So maybe there were two possible developments. The Panama was built, which is what actually happened, or the Panama might not have been built. Huge mountains were moved to build the Panama Canal. And in accordance with general relativity, the distribution of mass determines the shape of the world. So if we believe simultaneously in free will, general relativity, well, I don't know, we need to believe in much more than that, then the shape of the universe did not have to be what it is. Okay? Certain masses were moved that made the shape of the universe, in accordance with general relativity, be something which it wouldn't have been if the Panama Canal hadn't been built, and if Theodore Roosevelt in his study hadn't taken that fateful decision. So I think what we've got to do, is, you see, this assumption that we're just dragged across the world, whose shape determines everything, is not really part of general relativity. It makes an additional assumption. And what I think is the correct way of viewing general relativity is this, that after things have happened, then things, how can I say it, the trajectory of a particle in the world is a function of its shape. But the shape might have been different. Nothing in there says that the shape has to have been determined in some sense before it happened. So general relativity is quite compatible with free will. Okay, well, sorry, this now goes back to cats run backwards. I've seen plenty of cats. I can't develop a sort of coherent theory of their behavior, except that if you push them one way, they usually resist and push in the other way. But they don't run backwards. Maybe they withdraw backwards when they're ready to spring on a mouse or something. But how can it possibly have come about that intelligent people have been convinced that the laws of physics are time reversible? They're just not. It's just totally false. And if you believe this and are going to use it as some part of an argument, it behooves you to say something about the fact that they don't seem to be reversible. It seems to be totally false. Now, what's interesting about this is where the failure of predictivity sort of comes into the world. And do you remember I used a little diagram like this at some earlier time? The unitary development is happening here, and then there was a collapse to a point. I believe, not that this is really part of my message, that in practice the unitary development is interrupted sometime by an interaction which is decoherent, as they say, and you get this collapse to a point, or to essentially a localized state. These aren't necessarily points in real space. They're in state space, whatever it is. This part is predictive. This part has the free decisions in it. Okay? The part we don't understand, I'm afraid it's located securely in the part we don't understand. We never will, I think, but anyway, that's that. Okay, I think I may have come to an end. Yes, I have. So let me say something about this, what's happened. I wanted to deliver a sort of rousing peroration in favor of free will. We can't prove we have free will, but it's the only reasonable explanation for what the facts are. That it's the only reasonable explanation for why physics is non-deterministic. It's non-deterministic because, well, free will exists, and free will implies it's non-deterministic. After all, if you are in a criminal trial, the man who's found with the bloodstained knife in his pocket has some explaining to do. Okay? It might be totally innocent. We can't possibly establish a logical relationship between what happens, but if the facts can be explained by supposing he was the murderer, and they can't be explained by the opposite assumption, then probably he was the murderer. Okay, I'm going to end early. So that's it. I feel I ought to say one thing. It's okay to believe in free will. There's no compunction to believe in determinism. This, I mentioned Dennis Overby. There's no reason to believe in determinism whatsoever. There's never been any evidence for it that hasn't disappeared with the development of quantum mechanics. It's the natural thing to believe. Seems to be true. If you disbelieve it, you ought at least to come up with some evidence. I don't believe anybody ever has. Okay.